Ladies and gentlemen, please welcome to the stage Red Hat's Senior Vice President, Customer Experience and Engagement, Marco Bill Peter.
Good morning, good morning. What a great day. Day 3 of Red Hat Summit. How have you learned this? What have you learned the last few days? You heard it from the videos, amazing. A lot of new things to learn. Now, yesterday, Paul Cormier talked about bold ideas, shooting for the moon, and how to execute. But having ideas is one thing. Having ideas and innovate while running a smooth operation, a stable operation, that's a whole different thing. Now, today is all about innovation and the future and how it's shaping up. It's happening today in startups. You've seen startups change the development process. They changed how much they release, how many times did they release, a day or an hour. It's happening. But you know what's more exciting for me? What I've learned the last 2 days and what I've learned the last few years visiting clients? It's happening in global enterprises as well. It's not just happening in startups. And that's really proud and really great achievement of you all to innovate while running a smooth operation. And when we talk about innovation, especially at the Red Hat Summit, there are, of course, the Red Hat Innovation Award winners. We heard about them. This year's Innovation Award winners were BP, Deutsche Bank, Emirates NBD, HCA Healthcare, and Coles. We heard from Deutsche Bank already, from Coles and from BP. And later today, from Chris Wright, we hear about HCA Healthcare and the Emirates NBD. But before that, we're going to talk about innovation and how Red Hat supports you through that life cycle, giving you stability, security, guidance. I also say accountability and influence. Let me talk more about that. Having ideas, having bold ideas and making them a reality, you know, that needs a really, really trusting partnership with your partners and with your suppliers. We understand that. We understood that for the last 20 years because we were always an ecosystem around your IT needs. This is where my organization, Customer Experience and Engagement, comes in. Red Hat products are not just software. They are subscription. In the subscription, you get software, but you get also life cycle. You heard about RHEL 8. We have 10-year life cycles, 13 years life cycle to make sure you can operate safely in those times. It's also security, product security. I'll talk a little bit more about that. But I also mentioned accountability. What does that mean? Accountability means to have the expert knowledge from the technical support, from the trusted engineers who built the software that can provide you real answers and changes. You know, a lot of people say, supporting open source, that's easy. Well, it's open source, but trust me, it's not. Because if you got to analyze software, starting from the middleware layer, into OpenShift, into the Linux, into further down, these levels, you got to understand all the levels. You got to be able to diagnose it. But then you find the issue. What do you have to do? You got to produce a patch. It's not just patching that system. You got to patch it so it aligns with upstream, because we don't fork. But then you also got to align with our software so we can stand behind it for the 10 years of the life cycles. That is real accountability. If we don't support it, it's not because we want to be difficult. If we don't want to support it or we can't support it, it's because we can't stand behind it. We don't have the partnerships or the certifications, or we don't know the code. Now let's talk about security quickly. Patches for security vulnerabilities are great, but not enough. Give you a quick story. A company I know, they spent 18 months on a 15% performance improvement. They have 10,000 of servers, so 15% meaningful. The next week, a security vulnerability comes along, could wipe out 20% of your performance. Your 18 months effort is gone. That's where the product security team comes in to really give you guidance, as in, yeah, here you got a patch, here you got to adjust these firmware settings, here you got to adjust that. That is the real value. That's how we build the customer experience at Red Hat to be meaningful and valuable for you. I mention it every year. Customer experience at Red Hat is at the core of what we do. We don't squeeze or outsource support to save cost. We understand this is really, really really important for you to succeed. That's how successful customers engage with us, and we hope to do that. Keep in mind, having a smooth operation is the foundation to enable innovation. Now, speaking of innovation, I want to talk about previous winners, not about the winners from this year, because I want to show that previous winners keep innovating. And I want to talk with two clients. They have really good reputations to protect. At the same time, they got to innovate around their bold ideas and stay relevant for their clients. The company Hilti got recognized in 2009 for standardizing their large mission-critical SAP landscape on Red Hat Enterprise Linux. Let me welcome Christoph to the stage.
Please welcome Hilti Head of IT Infrastructure, Dr. Christoph Beck.
Christoph, great to have you here.
What a pleasure to be on stage.
Thank you. Christoph, tell us first a little bit about what Hilti does and what your department does.
Absolutely. Hilti is a leading supplier in the construction industry. We serve out of Principality of Liechtenstein about 120 countries with our services, solutions, products, and software for the professional construction industry. We are a family-owned company with about 29,000 employees all over the globe, and do about a 5.6 billion revenue a year. IT is for us a super important topic. Just to bring two facts to you. We are a direct sales company, so that means we have about 250,000 touch points with customers every day. That means we record all of them, including about 75,000 orders every day that we take from our customers. A second fact, our customers are very demanding. Think about a professional job site like out there. Customers do not expect to wait for their tools and products that they are ordering, so that means we are able to serve our customers in almost 99% of the cases in time. That means same day or 24 hours deliveries.
That is massive, and that's all running on your SAP landscape.
Absolutely.
And so back in 2009, Hilti won the award to move their landscape, the SAP landscape, to Red Hat Enterprise Linux. And you can see from the quote here, we wanted to bring up the quote here, we have a very long, 20 years or more relationship with SAP, and we have many customers that do that. But let me ask you, Christoph, how are you pushing the envelope today? What's the latest?
I mean, 2009 was a milestone for us. We moved from legacy hardware, from proprietary operating systems into open operating systems together with you with Red Hat, and together with Intel-based technology, not only for our SAP landscape, but for all our servers and databases. Now, in 2018, we did another bold step. We placed a big bet. Basically, SAP is pushing us to move to S/4HANA, and that meant that we decided, yes, we're going to go that way. And again, we placed that bet with our partners, Red Hat, and set up our S/4HANA system to run and serve our business.
That is massive. You know, like just moving straight, I was really impressed, worked with you on those years, to jump straight to S4 on the application side, on HANA, on the database. What made you confident you can do that step?
I mean, we were the first movers in that direction from a size and complexity point for SAP. So no company in our size has done that before. We talk about a 12 terabyte RAM system that we need to handle. Together with the partnership with Red Hat, that was then working out. And we could only do that because we trust in Red Hat, we trust in our partners that we have. And finally, it was the personal relationships as well, and the trust that we had with all our our partners, in particular Red Hat, that we were confident to pull that through.
Yeah, and I remember just 2 days after the go live, we were all excited about the go live. I knew it was successful, and we were sitting in a plane together by coincidence. And I was really happy to tell Christoph that we just elevated our competence center in SAP in Walldorf. So it was great coincidence.
And that showed to us that we bet on the right partners and on the right systems, because you continue to advance up to today.
That's great. Christoph,
thank you very much.
Thank you very much to have you on
Marco.
stage. Thank you.
Thank you.
You know, Jim Whitehurst always gives a history lesson every year. I give a little geography lesson with having a customer from Liechtenstein here. Now, let me welcome another Innovation Award winner on stage. In 2018, UPS built this innovative solution on Red Hat technologies like OpenShift Container Platform, Fuse, and Red Hat Enterprise Linux. They recently migrated their largest mainframe application to OpenShift. In December last year, they exceeded 1 billion transactions per day on several occasions. Pretty amazing. Let me welcome Ken from UPS to the stage to tell his story.
Please welcome UPS President of Information Technology, Ken Finnerty.
Hi. Good morning, everyone. It's a pleasure to be here today and highlight how Red Hat is playing a key role in UPS's digital transformation. You know, I think all of us, regardless of industry or geography where we're working, share one common thing, and that is that we're facing increasing competition in our marketplaces. We might also, though, find increasing opportunities as well. And I think you'll all agree with me that reacting to both of these conditions requires technology, specifically making clever and innovative use of technology. But futurists tell us that windows of strategic advantage won't last as long as they once did. And to us, that means that we can't afford to be good only once in a while. We need to create technology organizations that can continually deliver value. And that requires a modular design for your software, along with modern tools and platforms. And all of those things need to coexist in a healthy and productive technology ecosystem. You know, to UPS, being digital means having the ability to action the important events that occur within a supply chain and do that through software. For us, it means affecting the moments that matter to our customers and doing it without heroics. You know, there's an old saying that a good idea is worth $1, but a plan to implement it is worth $1 million. Well, at UPS, we have a plan. We're building a global smart logistics network, one that is fully digitized and operational in over 200 countries and territories around the world, and delivering 21 million shipments every day. We're already using technology to provide mass personalization to customers. We're simplifying shipping, delivery, and returns. We're removing friction from the e-commerce marketplaces, and we're even helping our customers improve their sales through increased digital traffic. Let me tell you how. UPS My Choice is our flagship digital engagement product. We have over 59 million members signed up worldwide. And this offers those members a personalized delivery experience, a personalized and flexible delivery experience. It's personalized because the members can go online, save their delivery preferences, which we honor, but it's flexible too because they could make changes to that on an ad hoc basis, shipment by shipment. And they could do all of that without having to pick up the phone and call UPS. And shippers also enjoy the benefits of My Choice because they can promote their brands in the electronic notifications that we send to consumers. And consumers receive those through 3 channels: through text, through email, or through push notification if they have the mobile app. One of the best features about My Choice is that it offers consumers the ability to redirect deliveries to an alternate delivery location. We call that UPS Access Points. That's a network of more than 25,000 retailers worldwide, and they'll receive and hold deliveries for consumers who can't be home to receive them during the day. Giving consumers a simple digital way to manage their deliveries improves the experience for all parties involved in e-commerce. It improves the experience for consumers because they enjoy proactive shipment notifications along with flexible delivery terms. It improves it for sellers and shippers because they experience a reliable service that includes digital promotions. And it's good for UPS as a carrier because we improve our operating efficiency. Now you can see how My Choice creates value in the marketplace, but I could tell you as a technology person that it also demands a healthy ecosystem, one that begins with a modular software design where business services are exposed through web APIs. In other words, it requires application building blocks. However, one of the things we found was that building blocks alone don't make up the whole ecosystem. No, we needed a platform that would allow us to deploy, to support, and most importantly, to scale as we innovate. Enter Red Hat. We picked OpenShift because it is highly scalable. It's an enterprise-ready container platform with powerful orchestration through Kubernetes. It has become a foundational element for us. It's enabled us to realize our cloud-native microservices architecture because after all, we want to go beyond the 12-factor app. Now, pairing our cloud-native microservices apps with Red Hat has given us the foundation to process those billions of transactions that you just heard about and provide customers with accurate and timely shipment information. Now, along with OpenShift, we've also deployed other tools in our tool chain, things that allow us to do build orchestration, to do automated testing, and also to instrument our applications. All of these things working together in harmony in a technology ecosystem have enabled us to reduce our deployment windows, to increase our change control success, and to improve our overall system uptime. Having Red Hat's team of experts working with us on our journey has provided valuable insight and knowledge, and it's accelerated our success. They've been a true partner to UPS. We all know transformation isn't easy. It requires a robust technology ecosystem. It requires talented and engaged people. And it requires a process that's fully automated. Now, Red Hat gave us the foundational elements for our technology ecosystem. It's an ecosystem we're using to create a global smart logistics network. Thank you for allowing me to share our story today.
Thank you, Ken. This was awesome. Unbelievable logistics. Now, innovation doesn't stop because you achieve something, you win an award. After every success, you actually have more opportunities and you can take greater risks because you have established a culture of innovation, a culture of change. That's really important. And Red Hat will be there for you, not just with bits and bytes, but a company standing behind you with a real partnership. Everything you do with us and every time we have an interaction with you, it only helps us to make our products and solutions better. Better for the ecosystem, better for the open source community, but also better for your business. Thank you for being awesome customers. I earlier teased the Innovation Awards. We're getting closer to that, so stay around Chris Wright's keynote and the demo from Burr Sutton team, and then we will reveal the 2019 Red Hat Innovator of the Year that you voted for. At this time, I would like to hand the mic over to Chris Wright, our CTO and good friend of mine.
Please welcome Red Hat Vice President and Chief Technology Officer, Chris Wright.
All right, good morning. Day 3. Thank you, Marco, and thank you to Hilti and UPS. You're doing amazing work showing that you have to constantly embrace change and new innovations to stay relevant. We know that business is ever changing. You have to continually adapt to changes in technology, needs, and demands. All of this while meeting your customers where they are. Now, over the last couple of decades, we've seen a cycle of innovation. It's not only fundamentally changed our view of IT, but also business and even society. The ubiquity of the internet, open source, smartphones, DevOps, big data, and cloud. Red Hat has been your trusted, stable, and open source platform through all of this. A common platform where you can innovate and not worry about availability, flexibility, scalability, security, lock-in. Now we're entering the next round of innovation, the data-centric economy, the mass adoption of AI and distributed computing. True innovation and disruption doesn't come from technology on its own. True innovation happens when new technology connects people and new ideas in your business. Disruption comes from the culmination of incremental improvements in technology paired with creativity, diverse ideas, and open processes. How you actually apply that technology to create something entirely new. An important enabler for this is the ability to utilize technology without undue hurdles, a quick time to value, stability, a platform that enables you to focus on the innovation in your core business. Now, throughout my time with you today, we have a lot planned. We'll see how Red Hat's platforms built around RHEL and OpenShift are truly your trusted platforms for the next cycle of innovation. And we'll hear from software partners that are helping operations and developers use AI and ML in novel ways. We'll show you how these new capabilities are helping business deliver value in disruptive ways, not only for themselves, but for entire industries. But before we get too deep into the software and platform side of things, everything starts with hardware. Without hardware innovation, we can only squeeze so much power out of our platforms. And modern innovation using AI is hardware accelerated. Hardware is changing. Moore's law is hitting the laws of physics. And the next round of hardware innovation is about specialized hardware, especially for AI. You see Google with TPUs, Intel with DL Boost, GPUs, even FPGAs. Now, during my keynote last year, I talked about performance and tried to make the raw numbers very real, normalizing a CPU cycle to 1 second. Now, with that time normalization, we saw that advancements in hardware reduce the time I/O operations take from months to days and even hours. And that was a year ago. We were looking at CPUs with just under 30 cores compared to more than 5,000 cores for a modern GPU at the time. What a difference a year makes. The same convolutional neural net training that I tested last year is 56% faster. We're also seeing the performance improve as much as 2 times within the same power envelope. Now, this is great for inference deployed at the edge, for example. But in the post-Moore's law world, this isn't just scaling up hardware anymore. Achieving maximum performance out of hardware also depends on end-to-end optimization. The hardware and drivers, optimized network fabric, specialized tool chains, optimized software stacks and AI frameworks, and of course, applications. A partner in this effort is the leader in GPUs, Nvidia. Nvidia has been with Red Hat all along, ensuring that their newest hardware capabilities are available and supported end-to-end in our solutions. To help tell this story and to show you what you can do with all these optimizations, I'd like to welcome Chris from Nvidia to the stage.
Please welcome NVIDIA Vice President, Computing Software, Chris Lamb.
Good morning, and welcome everyone, and thank you, Chris Wright. Nvidia and Red Hat have a long history of working together to deliver enterprise-class, high-performance solutions. I've worked on CUDA for about 12 years now, and I remember back in CUDA 1.0 how key it was for us to launch with Red Hat. And here we are now, 10 generations of CUDA later, and we're working closer than ever. Most recently, we certified Red Hat Linux on DGX, our enterprise-class AI supercomputer. We now have Red Hat virtualization integrated with vGPU for virtualized graphics, and of course, OpenShift support on NVIDIA GPUs. I'm talking to you now at a critical time in computing. Moore's law has ended, and data is exploding. And it's completely clear that in this new era of computing, acceleration is going to be the key that allows our data centers to continue getting faster. Now, NVIDIA GPUs are the most widely adopted accelerator across the industry, and this is for a really good reason. Solving this problem requires an accelerator that is programmable across multiple domains of software, but within a single architecture so it can be deployed everywhere. And this is a really hard problem. It's a full stack acceleration problem. You have to do optimization from the hardware to the firmware to the drivers to the communication libraries, algorithmic libraries for data science and machine learning, framework optimizations all the way up to the services and the application layer itself. It's a really difficult problem. And this is one of the reasons why we've taken that stack, an optimized version of that stack, and put it inside containers in NGC. So there's a repository of fully accelerated applications with their stacks across multiple domains. An example might be the major AI training frameworks, or Rapids, which is a Python-based framework for accelerating common primitives in data science, such as extract, transform, and load, or classical machine learning algorithms. So ultimately what we want to do is we want to make it easy to install and run these optimized containers on OpenShift. Our goal of working together here has been to simplify the deployment and management of this full stack needed for this era of accelerated computing. So let's start with operations. You're an operator, and let's see a demo of how easy this can be. OpenShift 4 makes installing the cluster really easy. It reduces the install time from the better part of a day to less than an hour. So here you see OpenShift 4 installed on a bare metal cluster in our lab. You've got 3 bare metal master nodes and then 3 worker nodes with GPUs installed. So then let's install CUDA. Using the GPU operator, this is really, really easy, and the upgrades going forward are easy too. This also installs a monitoring stack that gives you metrics so you can make sure you're getting great utilization of your GPUs. This is something that we hear again and again from our customers is really important, that you're getting good utilization out of them. Ultimately, the point here is to make it easy for a data scientist to launch one of these optimized NGC containers from a web console with just a couple of clicks. So let's now switch over to the persona of a data scientist, somebody who wants to set up a accelerated Python notebook. So here we're setting up Jupyter Hub on OpenShift so that the data scientist can spin up a notebook on demand. The one here we're using uses the Rapids framework so that somebody could work, say, with the dbScan clustering algorithm. Ultimately, this is what's going to make it easy for a data scientist to just go get the resources they need on demand. So in short, what you've seen here is a preview of what accelerated AI and data science looks like with OpenShift and Nvidia. We are really excited to work with you, our joint, current, and prospective customers to join us in a developer preview to try this out with your AI teams and your workflows. And ultimately, our aim is to make it easy to deploy clusters on-prem and in cloud environments. We've got a blog talking about preview access and how you can sign up to be part of our early access program. And we're also working with leading OEMs to make it simple to get starter kits for GPU-accelerated OpenShift clusters. So if you haven't had a chance to stop by our booth in the expo and come by and see what we're doing, please do. We can share more on what we're doing in our work together. Thank you all. Enjoy the rest of the show.
All right, thank you, Chris. Having Nvidia's hardware work with our latest platforms is crucial for these workloads. So with all of this impressive hardware, delivering better AI performance throughput in RHEL and OpenShift, we need to talk about the people keeping that hardware and those platforms running. It's operations. Modern software stacks are increasingly complex. OpenShift and containers make it really easy to develop and deploy, making it available on demand. But we know that operations can be a thankless job. You have pressures from the business to deliver more with less. You have to keep everything running. And you have to look for ways to make that ever more efficient while delivering new capabilities for your developers and applications and ultimately your customers. But the unexpected happens. You have, hopefully infrequently, hardware failure. You have demand issues that go beyond what your hardware and infrastructure are planned for. You have puzzling performance issues to track down, discover why they happened, and fix them. Now, with Murphy's Law, you expect the unexpected, you just don't know when. This is where AI can help. To enable innovation, you need everything running reliably. And that means enabling ops to be better than ever. The operational paradigm of the cloud offers a service abstraction that encapsulates operational excellence. But in order to enable you to innovate, that concept has to meet you where you are. This is where AI ops comes in. We're really talking about autonomous clouds, self-driving clusters. AI ops is the combination of platforms, big data, and AI ML that enhances practices like performance monitoring, event correlation and analysis, and management. At Red Hat, we're actively enabling this with solutions like Red Hat Insights and core concepts in OpenShift 4, such as operators. With AI ops, the infrastructure learns from the data and gains the ability to predict issues before they become problems. An example of a partner who is doing incredible work in the AI ops space is ProphetStor. Their solutions are being built on OpenShift and enhance its scaling and scheduling capabilities. ProphetStor and AI ops help operations teams predict and optimize workloads and resources in your cluster. And now, I'd like to welcome Brian to show you AI ops in action.
Please welcome ProphetStor's solution architect, Brian Jiang.
Thanks, Chris. So as introduced, I'm Brian. I'm a solution architect over at ProphetStor, and I'm going to be talking about our AI ops solution, Federator AI for OpenShift. So Federator AI, what we do is we simplify the cost optimization process for both day one and day two operations in OpenShift. For day one, as many of you know, there's hundreds of cloud providers out there, each with their own instance types and price structures. And new users to cloud environments might not readily know which cloud provider to choose, or even know their own application workload, right? So that's where we come in, ProphetStor. You just tell us the application and the optimization policy, and we'll recommend which cloud provider and instance type to choose based on that profile. So we do all the legwork for you, right? And then for day two, that's where our machine learning AI comes in. We learn the resource usage of each pod in your cluster, and we predict future resource usage. And with those predictions, we can apply it to the native Kubernetes scheduler and autoscalers for a much more intelligent resource utilization than the current historical algorithmic method, right? And from these two solutions, you can kind of see that we're being a force multiplier with OpenShift to enable your team to streamline operations, save resources, and allow them to manage systems more efficiently and in less time. So just some more details about our day one solution. The user tells us what application he wants to deploy, about how many requests per day, and the optimization policy, whether it's cost, performance, SLA. And from that, we'll generate which cloud provider and instance type to deploy your application into. But if the user also wants to deploy directly into his own cloud, we can just directly recommend how much resources he'll need in terms of CPU and memory. And then day 2, as I said before, that's where our machine learning AI comes in. We predict the future usage of each pod, and we apply it to the native Kubernetes scheduler and autoscalers. And according to our test results, we can improve your resource utilization by 60%, right? So if you guys can see the graph behind me, there's a white dotted line, which is our predicted CPU usage. And it's about 10 minutes ahead of the blue solid line, which is our current observed CPU usage. But you can see that these two lines are really intertwined, which shows that our prediction engine is really accurate at this point. So with these accurate predictions, we can recommend where to put your pod request and limit at, which is the green line and yellow line, respectively. And we can also automatically execute these recommendations, so your operators don't even need to worry about scaling the cluster themselves, right? Okay. And then let me just switch over to a web browser. This is a Grafana environment. It's a side-by-side comparison of the native Kubernetes horizontal pod autoscaler and our Federator AI horizontal autoscaler. And I'm just going to be calling it a HPA from now on because it's shorter. But you can see we found that we outperformed the native one in these 3 main categories, right? For the same identical workload, we can use 19% less replicas. So that's directly saving you 19% resources, right? And then we can also reduce your CPU over limit instances by 61%. So every time your application hits a CPU over limit instance, it gets performance issues and slows down. So it's really big that we help out there. And actually the biggest thing right now is we reduce your out of memory instances by 90%, almost 90%. Every time an application hits an out of memory issue, it stalls out and crashes. So you want to avoid these at all costs. We do that 90%. So this is a Grafana environment. There's all this data. We have a booth that you guys can go over with us later about it. But just know for now, this is only a side-by-side comparison of the HPA, the horizontal pod autoscaler. But we can be applied to the vertical autoscaler, the cluster autoscaler, the scheduler, and all these different facets of your OpenShift cluster can be optimized using machine learning AI with our Federator AI solution, right? And the really cool thing is that once we have those usage predictions of each pod, the future resource usage, we can feed that back into our day 1 tool. And you can get new recommendations of which cloud provider and instance type to choose. So now your full stack from your resource usage all the way up to your cloud provider is fully optimized using Federator AI, ProphetStor, right? So that's it. We're going to be in the general section. We have a booth 1134. If you guys have any questions or want to get more details, come say hi, talk to us. Thank you.
So we're using AI and machine learning driven algorithms to help keep operators operating. As you just saw, we're using data to make predictions for the future, keeping containers and pods running within set standards. Our apps, built on top of OpenShift, can automatically adjust and become more intelligent out of the box. And the key here is data. We have data. The dataverse is growing exponentially. I saw numbers recently from IDC. Half of the world's data has been created in just the last 2 years, yet only 2% has been analyzed. So how do we connect data to your business to create true innovation? Let's talk about AI as a workload, how we help you innovate with AI. Developers need to be able to use AI. They need to simplify these complex activities and have access to meaningful data. The work of training models and connecting that to apps has historically been done by small groups of highly skilled data scientists. In a traditional AI workflow, data scientists are a precious resource, but they can become a bottleneck. So we need to enable developers to help data scientists scale. OpenShift enables AI innovation for the developer. This benefits users as apps are able to move more intelligently faster. Now, my next two guests are democratizing developers' access to AI in different ways to make the AI workflow easy, intelligent, and accessible. You'll hear from PerceptiLabs, who've made their deep learning model training as simple as a mouse click with their drag and drop interface. And that's fantastic for instances where you know what your data is, but you just need to apply it to glean the insights, or in this case, return a result for your customers. Then you'll see how H2O AI is approaching the problem of massive amounts of data, where the model you should use isn't clear. Thanks to work from companies like PerceptiLabs and H2O AI, developers now have access to AI platforms built on OpenShift, made with them in mind. I'd like to welcome Martin and Robert to the stage to show you how to train and teach your AI to do powerful things the easy way.
Please welcome PerceptiLabs Chief Executive Officer, Martin Isaacson, and PerceptiLabs Chief Technology Officer, Robert Lundberg.
Hi, I'm Martin.
And I'm Robert.
We are the co-founders of PerceptiLabs. Unlike many Silicon Valley startups, PerceptiLabs was not built in some Bay Area garage. PerceptiLabs was built in a Swedish garage. So to start with, how many of you have ever worked with AI? Let me see you raise your hands. That's some. For those of you who don't work with AI, take my word for it. Developing an AI model can be a long, tedious, and complicated process requiring specialized knowledge and skills. Well, we now have a solution aimed at simplifying that process. We built a tool that helps enterprises save time and money when creating AI models. We simplified the model development process by substituting math and code with a simple drag and drop interface. And we built all of it using UBI-based containers on Red Hat OpenShift to make the deployment quick and easy. Okay, so let's just show you how it actually works. And I just want to mention that if we wouldn't have been running this as containers, we would have to wait at least 5 minutes for the virtual machines to start up. I'm just saying. Anyway, to your left, you see the different operations or the ingredients of the AI. In the middle, we have the workspace where we can mix all different kinds of operations. To your right, we see a project menu, and on top, a toolbar. Pretty simple. And we're going to do this a little bit like a cooking show, where we first will build or bake a model from scratch and start training it in the oven. So we created a data set containing images of red fedoras or red hats. And we want our model to learn to classify if an image contains a red fedora or not. So let's load this data into a data set on the workspace. And we will be able to see a sample to verify that the data looks like as we expected. And you can continue to use this drag and drop interface to build out the entire model workflow. But here we will switch over to a complete workflow and show you the complete process. So we can see the image data layer on the workspace. We have also loaded the label data or the ground truth into another data layer. And this is what our model's output will be compared against during training. And we set the output size to 2, since we have 2 classes, Red Hat and not Red Hat. And in the platform, we can define what sort of AI technique we want to use by choosing a training layer. And we can select from multiple options, including reinforcement learning, genetic algorithms, dynamic routing, and so on. But here we will choose normal supervised learning. And if you're too lazy to set the hyperparameters manually, you can do it like us and auto-generate them. Well, let's start training our model. First, we'll set some general settings, for example, for how long we want to run the model. We automatically get thrown into the statistic dashboard where we can see various kinds of metrics. And this might look a little confusing at the start, but Robert is here to walk us through it step by step.
Thanks, Martin. So we see our 3 different boxes. At the top, we have the statistics for a training layer. This shows the overall performance of the model. Here we can see things such as the Okay. And we can see things such as the input to the model or the current accuracy. We can also see the network output in blue compared to the labels in yellow. And just to the right of that, we see the same thing, just average over many to give you a nice distribution. If you want to keep track of how the model is progressing, you can swap over to accuracy and see it there. At the bottom right, we have something which we call the view box. It's like a peek hole into a model, where you can peek into all its different parts. You can select which part you want to look into by clicking on the map over to the left. This gives you full transparency of what's going on inside your model while it's training. You can see things such as the output, the biases, or even the gradients. And if you ever want to, you can just pause your model, change some things up on the workspace, and then keep on training. Okay, so it looks like the model has finished its training. So let's go to a test view to see how it would perform against real or live data. Now, it hasn't really trained for that long, so it's not going to be that good. But if you want to know how it works, we have a clickable map right here as well. So if you're satisfied with your model, you can just go over to here, and you can export it as either raw digits, a TensorFlow model, or a container image coming with a full API. So the key points we want to highlight are the simplicity and efficiency of modeling. A nice looking dashboard allowing you to custom edit allowing you to help with both understanding and with error searching. All built upon a very flexible core, allowing you to custom edit every component. And finally, the ability to perform cutting-edge AI on OpenShift. Okay, Martin, do you want to talk a little bit about how the audience can engage with this?
Sure. This model is hosted in OpenShift, and we can communicate with it via Twitter. So we gave this a try and uploaded a picture of Robert wearing a red fedora. And we got the response that it classifies correctly, and you can try this out yourself. Just go to Twitter, upload a picture, and mention @FedoraFinderBot, and it will tell you if it thinks there's a red fedora or not in the picture. And this will be running through the entire day, so have fun with it. We will be hanging around the emerging tech booth if you want to come and see us. So, in closing, we just want to say, containerize it. Thank you.
Please welcome H2O.ai Chief Executive Officer and Founder, Sri Ambati.
What an amazing demo from PerceptiLabs. Thank you for having us, Red Hat. We're so excited to be here as a partner of OpenShift and bring AI to everyone. Open source is about freedom, not free. It's about culture, code, and customers, ardent customers like you who supported us over the last 7 years and supported Linux over the last few decades. Thank you for your support, community. We are really excited to talk about driverless AI. Automatic machine learning has come of age. There are 5 common steps for large and small enterprises to use AI. First, you need to drag and drop your data, so connectors to your data sources is key. Then you want to do quick data sense. You want to understand how your data is laid out. Automatic visualization allows you to understand your data in quick, simple ways. Finally, data scientists are the most wanted talent across the world today, and automatic machine learning augments them to enable build models of high quality and deploy them quickly as scoring engine pipelines. H2O's driverless AI allows you to prevent the common pitfalls in doing data science, like overfitting, and automatic feature engineering allows you to get that extra to get your model with that into production. Finally, trust is so important in AI. Your models are not trustable if you cannot really interpret them and explain them. So explainability is key, and that's kind of the final step before you can take a model to your business user. Let's look at how this works in real time. We deployed our models, our software, on the OpenShift container platform. And driverless AI allows you to connect to several data sources, whether it's traditional file systems on the cloud, or open source object stores like Minio, or time series databases like KDB. We have a simple demo set up for us here to understand sentiment analysis of the conference. Classic Twitter data sets, correlation graph, which allows you to understand the hidden structure inside your data and its dimensions. Let's run a simple prediction. Classic test and train in your data set, and looking for conference sentiment. We'll just look at text. NLP is the heart of all AI. Obviously, you can use not just one framework, multiple frameworks, including H2 open source, XGBoost, gradient boosting machines, TensorFlow, Torch, and your favorite algorithms of choice. H2O's driverless AI now allows you to tune, eliminate features that are columns that are collinear, or common pitfalls in how you do your test and train division, your validation set, preventing leakage of data and signal. Time series, text, and transactional data needs a lot of nice recipes, smart recipes that can allow you to come up with the best signal from your data. Right now, you're seeing automatic feature engineering from the data and pulling up signal so you can quickly improve accuracy of your model. We ran an experiment earlier and deployed that on OpenShift. About 400 features have been analyzed across in just a matter of few minutes. Several of our customers have built models to democratize credit, to prevent fraud prevention, to save lives, and you'll see one of our customers later who's using it to fight sepsis across multiple hospitals. Now it's time to deploy the model. H2O models generate code automatically so you can deploy them as real REST endpoints. And so Red Hat Summit has been a beautiful, awesome experience for all of us. I'm really excited to show that the conference sentiment on this has been spectacular. Finally, OpenShift allows us to truly democratize AI and take it to where developers and data scientists and DevOps for machine learning can truly get. AI is a very powerful way to build code. Data is automatically generating code for you using AI, and we're really excited to democratize it and make it for all. Thank you for having us.
Creating ecosystems of solutions for our customers will always be important to Red Hat. However, it's also important to consider how our customers are innovating. With our ecosystem partners, customers, and the broader open source community, we're creating the trusted platform for the next cycle of innovation. Together, we're enabling better hardware to drive AI and I/O. I know it's a little cliche, but in ways we've never seen before. We're enabling ops to be even more efficient by peeking into the future to predict issues before they become very real, very expensive problems. We're giving developers the tools they need to train their applications to take advantage of historical shared data to make decisions. We want to create the right primitives and connective tissue in the platform to enable a broad ecosystem of specialized solutions. Now, at Red Hat, we focus on the upstream. Key open source projects in this area are Kubeflow and Open Data Hub, which you can learn more about today in the emerging technology track. Now, all of this innovation delivers value to some organizations and to customers. But what is value? We can talk about money, saving money, or expanding and creating new sources of revenue. But technology and innovation isn't only about money. I want to talk about value that's beyond financials. Value to some organizations is related to health, where delivering value means keeping people alive. It's important to enable innovative customers who understand how innovation impacts both technology and people, like HCA Healthcare, who is one of our Innovation Award winners today. To tell their story, I'd like to introduce Dr. Jackson.
Please welcome 2019 Innovation Award winner, HCA Healthcare Chief Data Scientist, Dr. Edmund Jackson.
Morning, everybody. When the organizers, Red Hat, told me that the theme of this conference was expand, I did not really appreciate that this meant the stage as well. This thing is vast. I could get lost up here. I'd like to start on a personal note to thank the open source communities, both our commercial partners such as Red Hat and Sri from H2O that you heard from just now, but also the non-commercial projects. The list of such projects upon which our work relies is long. GNU, Linux, Clojure, Elixir, Kafka, even our good buddy JavaScript. Without the contributors, the moderators, and the maintainers of these projects, our work would be impossible. So thank you. It's my privilege. Thank you, yeah. It's my privilege this morning to represent a company, HCA Healthcare. We're a Nashville-based healthcare provider operating 180 hospitals and about 1,800 sites of care across America and the United Kingdom. And to tell you one of our stories, Spot. One of the themes of our organization at Tray is a relentless commitment and energy towards improvement. A few years ago, our clinical leadership decided to take a bite out of sepsis. Sepsis, as you can see, is a body's overwhelming toxic reaction to a bloodstream infection. It's unknown, but deadly. When thinking about how to defeat sepsis, there are two important things. One, every hour that it goes untreated results in an increase in risk of mortality by between 4 and 7%. But if you can detect it, treatment is relatively easy as far as these things go. So the name of the game is rapid identification and even more rapid treatment. So we looked into our data to try and understand how we were doing. Here's the data for one hospital. Rows are days, columns are hours of the day, and the number in color represent the number of sepsis screens performed at that time. A sepsis screen is a unit of nursing work in which we look for sepsis in our patients. And you can see we're doing this at 8 a.m. and 8 p.m. Shift change. Now there's 12 hours between there, and in the fight against sepsis, 12 hours is too long. But our answer couldn't be, hey nurses, could you please do some more sepsis screens? Because nurses are already the most heroically busy people basically on the planet. So we had to get smarter. We looked deeper into our data. We used our data warehouse to look backwards in time. And we applied a really pretty simple algorithm, and we saw, hey, we can see sepsis in the data. If only we could do that in real time. If we could do it in real time, we could alert the nurses, we could coordinate a workflow, and we could give people the time advantage necessary to fight sepsis. If only we could do it in real time. Our IT teams, networking and data said, no worries, we got this. They've pulled data from all of our hospitals in real time to our data centers, 5-minute latency. That's awesome. Now we can do this. The Spot product teams pick up that data. They create a patient object that represents every single person under our care at all times, every hour of every day, and with every single transaction updates that state and looks for sepsis. If it's detected, it coordinates a pretty complex symphony of action and care in the hospitals to make sure timely care is provided. All of this is done on OpenShift, all of it. Now, the key point here is that data itself are worthless. Absolutely nothing counts in this world except action. And what Spot provides is not just an alert or an algorithm, it's a coordination of a very complicated workflow. It coordinates nurses who care about all of the concerns of one patient, sepsis coordinators who care about sepsis across all of the patients, and a management structure that cares about the performance of the entire system. But my favorite part isn't the lines of workflow. It's the lines of communication between those teams and also back from those teams to us. In the application, people can send us a message, ask for feature requests, report bugs, or just say hello, which sometimes they do. And as a standard practice, a non-heroic part of our business, we can turn around those feature requests in the same day. Zero downtime major version upgrades with OpenShift and our culture of empowerment, we've done that. But all of this technical juju provides one thing, a time advantage to our clinicians. What we provide them is a 5-hour head start in treating sepsis. And in the hands of clinicians, 5 hours saves lives. Every day, across over 150 hospitals. Spot the algorithm isn't the story here. Spot the platform is a system. We have created a system that will provide high reliability, care at scale, and allow us to radically transform the way that we, with our providers, improve lives and provide care. For us, it's that, the care and improvement of human life. Thank you. At this point, I was promised somebody would come and talk to me. There he is. Thank you.
All right, Dr. Jackson, I love this story. And one of the things we were talking about is, you know, the introduction of AI into the workplace and technology in general can actually make people uncomfortable, even a little afraid. And so one of the things I wanted to ask you about is, where do you see AI in the workplace and the concerns about job loss coming together? What does that look like for you at HCA?
It's a really key question, Chris. I mean, we deal with human lives. It's a sacred responsibility. And I think that I hope that Spot provides an example of the right way of doing it. We try to let the computer do what it does best. Look through data, identify patterns, coordinate complex workflows, which frees our people to do what they do, provide empathy, provide care, and dignity for people who are sick. And I think, you know, at this sort of Promethean time of AI, if we as engineers and creators hew to that line of trying to enhance humanity rather than compete with it, I think we'll be fine.
Thanks very much, Dr. Jackson.
Yeah.
I love that. So that's computers doing what they do best, crunching numbers, nurses doing what they do best, providing healthcare and empathy. Really, we're talking about machine-enhanced human intelligence. I think that's a great way to think about it. So I want to expand a little bit on healthcare and the implications of the work you just saw. We know that data is valuable. It helps you learn. It helps you do important work. Some data, however, is sensitive, private data, like patient records, for example. The tension here is that you need to be able to use this data while respecting the privacy of the party it's tied to. Patient records have to be kept confidential for both legal and ethical reasons, but we must study them. The future of medicine depends on it. Now, Red Hat, along with many other partners, have been working on ways to share and generate new knowledge across businesses around the world without sharing the data that must remain private. The result of this work is secure multi-party computing, or MPC. MPC is a cryptographic solution wherein multiple parties jointly make computations using private data from each party, some secret number, for example. Together, they want to compute a function using these numbers, but they don't want to reveal their private data. I know it sounds a bit like a magic trick, but let me quickly convince you that it can actually be done. So let's say I have a group of people who want to compute their average salaries. I choose a random number, add it to my salary, and pass the result to the next person. They pick a random number, add that number and their salary to the number I gave them. They pass the result on, and so on around the room. At the end, we have one very large number. Now I subtract my random number and pass it on. My neighbor does the same, and so on around the room again. When the result comes back a second time, it's now the sum of everyone's salary, which we can divide by the number of people. In the end, I know the average salary of everyone in the room, but no one has shared their salary with anyone else. Now you have to take my word for it that you can do this with any calculation with more efficient protocols, which you can. Imagine a city trying to do traffic planning without access to data from ride-sharing companies. Or patient info shared across multiple hospitals without breaching privacy laws or revealing sensitive information. Now, as fun as it is to talk about the theoretical use of technology, I'd like to make this real. Let me bring up someone who is exploring MPC right now to improve patients' lives. Please welcome Dr. Grant.
Please welcome Boston Children's Hospital Director, Fetal Neonatal Neuroimaging and Developmental Science Center, and Professor of Radiology and Pediatrics, Dr. Ellen Grant.
Good morning. Thank you, Chris. It's wonderful to be here and to talk to you about why we think multi-party compute is critical to the future of medicine. There's two ingredients, key ingredients to this future. One is Red Hat's infrastructure, and another is Chris, a platform we've been developing at Boston Children's Hospital. Unfortunately, Chris, ours has no relationship. Now, our Chris, what it does is it takes data in the hospital, such as images, and allows us to compute on the cloud. It leverages OpenStack for rapid analysis, OpenShift so we get reproducible results, and multi-party compute to securely compute across multiple enclaves. Let me walk you through an example of how this would work that is almost in production. Now, we have a 10-year-old boy that arrives in the emergency room with his parents. He's had multiple seizures, and of course, they're very distraught. One of the first things we do is get an images of his brain to make sure there's nothing grossly wrong. What you see behind me are multiple images from one of the many volumes of images that we acquire. There is one from the side, one from the front, and one from the top. So as a radiologist, I would be sitting now in the reading room looking through these in details, about 5,000 images in total, looking for any subtle abnormalities. I look closely, I review, and I don't see any abnormalities, so I call it normal. The patient has blood work done, has a neurological exam, and is basically normal at that point in time, so he's sent home on a standard anti-seizure medication. However, over the next years, or weeks, months, years, his seizures are not controlled. They bring him back, they try multiple different medications, he gets more MRIs, he gets other tests such as EEG, MEG, no focal onset is found, and so he goes on to have continuous poorly controlled seizures. That results in poor school performance and incredible family hardship. Now, is there anything we could have done different in this scenario? If I had more data and more compute, could I pick up something subtle earlier and guide more targeted therapy? Now imagine this child is in the emergency department again. An MRI is done, and the images are sent to me. Now, while I am visually scrolling through the images and looking for a subtle abnormality, I pull up a web interface called Chris. I select this child's images, and I go to the different plugins that we have that are all in containers, and I decide to choose one plugin called FreeSurfer, which does a detailed neuroanatomical assessment of this brain. I point and click, the data goes off, and before I'm even finished reviewing the images, which takes somewhere around 15, 20 minutes, the results are back. And this is a colored image you're seeing up here in your left. I've now detailed a characterization of that individual child's analysis. Some key features to notice. It was easy. I just pointed and clicked in a web interface. Using OpenStack, it is rapid. Using containers, it is reproducible. These are 3 key features to get anything to the front line of medicine. Now I have this boy's brain characterized in far more detail than I could ever do by eye. Even as an expert doing this for 25 years, I could not remember or even perceive this kind of detail. And I've characterized all these functional regions of the brain with volumes, surface areas, and incredible detail. And again, this was easy, it was rapid, it was reproducible, point and click back to me in the front line. But we don't stop there. I know now the detailed anatomy of this one individual, but I want to compare him to other individuals to see if, similar to him, to see if he's got a brain that's normal or whether there's subtle abnormalities. What if I could get detailed, similar information, not just from my patient records, but from many hospitals across the country, across the world, working together? This is extremely important in pediatric medicine because we have many rare disorders that may be only seen at a couple of hospitals. Or if we want to really get a good comparison to demographics, I have to bring multiple hospitals data together or my data will be skewed. So for example, if I want to get the same gender, the same age, and the same ethnic background, I need to pool resources across multiple hospitals to be able to get that data. Together, if I put all that data together and I can access to that, we have an amazing depth and breadth of comparative data that I could use to guide my decisions. Through our collaborations with Red Hat, we've now taken Chris to the next level. It communicates with the MPC infrastructure, and encryption is built into how Chris manages the MPC compute. We have set up a case of enclaves in the cloud with collections of brain data. Each enclave participates, but as Chris mentioned, no data about any individual is disclosed, so I maintain patient privacy at each of these individual hospitals. Now imagine I'm sitting there at the front line. I've now analyzed my data. I send it to the enclave to do comparisons of my index case, the patient I'm seeing, against this wealth of knowledge that we have now that we're sharing. The first question I ask is, how different is this brain from typically developing kids of the same age and background? And I get the results here. Red is keyed as standard deviations above normal, and blue as standard deviations below normal. So now I've exquisitely characterized how different this child's brain is from a collection of normal kids in a much more detail, again, than I could ever do by eye. But again, we don't stop there. I go back to this enclave, these multiple enclaves, and I search for matches in the same pattern of abnormalities with the same history of seizures. And we flag a result. There's a case that comes up, or a collection of cases from different hospitals, only few, and they suggest this may be very similar to this genetic disorder. We then get a blood test on the patient, and it confirms that rare genetic variant. That then allows us to give that patient a targeted gene therapy that specifically addresses the poor function that results in one process that results from that gene. So the child is given that initial gene therapy within, say, 2 to 3 weeks of us actually doing this MRI. His seizures are controlled, and he goes on to lead a productive life without the disruption of multiple tests and failures at other medications. Now, although this is a theoretical example, images used from an actual MPC calculation created this picture, and all was securely performed across several prototype enclaves. Now, this is the future of precision medicine. This is what we want to do, and this is not possible without the Red Hat infrastructure and Chris to bridge those two worlds together. And one other important point is that open source community, because our engineers, our lead engineer, Rudolf Panar, is working hand in hand with the Red Hat engineers. So there's no black boxes, and that's another critical point in medicine. I need to know what happens to my data. I need to trace it through so that I understand the analysis that I get. Working together in open source yet encrypted environments has now helped us share our collective knowledge to better serve and save while protecting individual identity. Together we are changing how healthcare works, and it's about time. Thank you.
These are awesome stories. Thank you, Dr. Grant. So these technological advancements, and more importantly, how they're applied, are obviously having a massive impact. As you've just seen from HCA Healthcare and Boston Children's Hospital, the innovation here is changing lives, the lives of patients and their healthcare providers. So it's really about fundamentally changing these organizations. And well, you really heard it from Dr. Grant. It's disrupting their entire industry. And it doesn't stop there. This massive shift of machine-enhanced human intelligence is making data actionable and usable, pairing truly innovative approaches and happening across many organizations. It's having an impact on those organizations' industries as well. Telecommunications, banking, even the way you interact with your car. They're all undergoing disruption thanks to innovation and thanks to Red Hat's solutions and platforms. Take something as elemental as the human voice, how we communicate. Sure, there's been advancements, SMS, instant messaging platforms, emojis, GIFs. These all help us communicate, but there's room for innovation yet, enhancing the human voice itself, changing not only how we communicate, but opening up the doors on who we communicate with in ways we couldn't easily do before. Please welcome Guillaume and Vasily from Optus to the stage. I think you're really going to enjoy what they're up to.
Please welcome Optus Senior Innovation Manager, Guillaume Poulet-Matisse, and Optus Principal Software Engineer, Vasily Chikalkin.
Good morning.
Morning.
For thousands of years, people have been talking to each other. In ancient Greece, Aristotle was walking with his pupils and having conversations that would revolutionize our world. Later, conversations have been carried through other means. In the 19th century, Graham Bell invented the phone call. Telephones have been used to carry conversations, whether it is a conversation about love, about war, or to make peace. In our modern world, we have a multitude of ways to carry conversations. Chat, emails, social media, you name it.
But phone calls are falling out of the fashion. There is this perception that phone calls are dead. In fact, it's lagging in terms of features. No emojis, no chat history, no multitasking. On the other hand, our voice is the most natural way of communicating. Many organizations are working on improving their products using voice. Voice assistants to answer your questions. Voice biometrics to authenticate you with your bank. Voice bots to improve service.
So, a little while ago, at Optus, we asked ourselves, can we bring modern voice technologies to the phone call? We have capabilities to establish and carry native phone calls. We have towers, data centers, fiber channels, but our mindset hadn't changed. Phone calls have remained wires and switches. So, how might we, as a provider of communication, challenge ourselves to rethink the phone call, to leverage our core capabilities and open a mindset to lead innovation within our very own network? Today, we'd like to show you a step change in how we see the phone call.
Good day, mate. How it's going?
Great. And you?
Feeling a little bit nervous and hope this demo goes well.
You know, we are making this call because we want to demonstrate some of the cool things that we are doing at Optus.
Let me keep a record of this. Voice Genie, start taking notes.
So this phone call is now being transcribed in real time?
Yes, And look at the potential. We just made this phone call open and digital.
You mean that we can integrate this conversation into different systems?
Yes, of course. Email, calendar, contacts. Can you develop?
For example, a web service?
Exactly.
Is this system only for English speakers?
Of course not.
Do you speak French?
Voice Genie. Translate into French.
This call is being translated by Optus Voice Translate.
Tu déconnes.
You're kidding.
No, I'm not.
Mais non.
Et je peux discuter de notre réseau télécom?
And I can discuss our telecom network.
Why not? Let's have a conversation about it.
Pourquoi ne pas nous en parler?
On devrait expliquer à nos amis de Boston comment ça marche.
We should explain to our friends in Boston. How does it work?
So, phone calls are a little complex. Voice is not asynchronous. You have to deal it in real time. And please do not drop way too many packets or delay them, otherwise you will have very bad quality. And let's look at the details.
John is in Perth, and he wants to call Mary to tell her about the weather. Mary is in Sydney, sipping a coffee and getting through her emails. When John starts the call, his cell phone is going to send a message to the tower. This message gets carried all across the country to Mary via our mobile call. When Mary answers the call, an RTP media connection is established between our Western Australia exchange and New South Wales. There is 4,000 kilometers between them. And if you don't want bad quality of service, you need to be cautious about latency. To avoid additional latency for the call, we must be able to deploy or virtualize media functions on the same path as the call, and it brings additional challenges.
As a software developer, you want a simple way to package your software in a portable format. And from an infrastructure point of view, you want to deploy this package in multiple geographical locations, have convenient means of upgrades, and monitor the health of the platform. From a carrier point of view, you want reliability and support, which brings us to containers and OpenShift. We package our virtualized network functions into containers, then we distribute them across our exchanges with OpenShift pods, and by doing so, we get benefits of a single platform to build, scale, and monitor our software. We do all of this while introducing a repeatable software development lifecycle for future innovation.
By abstracting the complexity of our network and harnessing software advances, we are opening a safe environment for software developers to build, deploy, and operate a new breed of telco applications. This is a unique opportunity to uplift equipment legacy into the digital age. Thank you for your time today.
Nice. Come on, that was awesome. All right, thanks Guillaume and Vasily. When you think about how Optus is changing phone conversations, you can see how new expectations for an old medium led to a game-changing innovation. It's remarkable to see how we're still iterating on something that's inherent to humans, communication. Now, the basic premise of banking has also remained consistent over the years. Advancements in digital technologies have led to a whole new set of expectations and places where you must meet your customers. This is something that Emirates NBD is acutely aware of, and they happen to be another one of our Innovation Award winners. So please join me in welcoming Ollie Ray to discuss how they're shifting expectations in a long-standing industry.
Please welcome 2019 Innovation Award winner, Emirates NBD Vice President, Cloud Platform, Ali Ray.
Hello, Chris. Great to be here.
All right. So thanks for joining me. Emirates NBD started a 4-year digital transformation project. Can you tell us about the goals and milestones of this project?
Absolutely. Emirates NBD is a leading bank across the Middle East. Over the last few years, with rising customer expectations and increased competition, we realized as a bank we needed to change. So with that, in 2017, we started a 4-year digital transformation. One of the first key tenets of that transformation was launching our private cloud based on Red Hat's OpenShift technology. We named it Sahab, which is Arabic for white cloud, and it was very much the enabler for our digital transformation.
So you just mentioned Sahab, my first Arabic word.
Brilliant.
And that was a major enabler for your transformation ambitions. So can you kind of walk us through some of the challenges and maybe some of the benefits you've seen over the last 18 months?
Sure. So we worked very collaboratively with Red Hat. We took the best of our internal IT talent and brought some great engineers from Red Hat on board to deliver our private cloud, which was very much a first for the region. From there, we looked at how can we deliver on our strategic goal. We wanted to really push forward with always available banking, very similar to utilities such as electricity, internet. How could we serve our customers 24/7, so banking whenever they needed it? But we also wanted to pivot. How could we change and innovate at speed? How could we deliver faster? We wanted to deliver in days and weeks, not months and years. So looking at these two strategic goals were very much an overall view of how the bank wanted to move forward with its international growth and expansion.
So you mentioned Sahab, and it's a key part of Emirates NBD's infrastructure. Now, how will you use this private cloud to personalize banking?
Great question. So Emirates NBD is continually looking at ways of pushing the innovation boundaries. We've adopted open source technology, and a great example of this is WhatsApp digital banking. We built this using plug-and-play APIs on our private cloud within 3 days. This would have taken weeks, months, years previously, and we've now launched that as a global first to all our customers. We're now looking at how do we move over the next couple of years 95% of our applications over to our private cloud platform by 2020 at the end of the year.
So you've called us more than a vendor, which I love. Thank you. Throughout this journey with Red Hat, what have you learned and what are you looking forward to?
So working with Red Hat was amazing. It was a fantastic experience. I think me personally, what I learned was we were looking at how we changed the culture of the bank, how we were driving forward with a new culture, and the culture that Red Hat brought really worked well with us. It enabled us to really achieve anything we wanted to do and move towards our vision and our goals collaboratively, which was great. Looking forward into the future, we've got some goals around as the public clouds become available in the region, we want to work with the partners and move more towards a hybrid model. We're looking at how we enable real-time banking with Kafka. And finally, we're working with a lot of our partners and vendors to move more of our critical workloads onto our private cloud, such as our core banking system. So amazing opportunity over the next year that I'm very much looking forward to.
That is awesome. Talk about expand your possibilities. Thank you, Ali.
Thank you, Chris. Thank you.
So one thing you've seen today is that starting with a single innovation, it's just the beginning for many of our customers. To deliver value from that innovation, Emirates NBD had to continually transform their business using data to personalize their customers' experience. This data and customer-centric approach is important in every industry, including the auto industry. Our next guest, Dr. Lank, is here to discuss how this transformation has taken place at BMW Group.
Please welcome BMW Group Lead Architect, Connected Vehicle, Digital Backend, Big Data, and Blockchain, Dr. Alexander Lank.
Hey everyone, I'm Alex. I'm with BMW. I hope you all know BMW. Company has been around for more than 100 years. We're building cars, have been doing this quite successfully. But in the recent times, not just the car, but also the digital services become more and more important to our customers. And even though if you know BMW, you might not know how the connected car and IT plays into that. So first of all, we have a product. This product is called Connected Drive, and it's basically everything that is in your car as a digital service needs to have some connection to the back end. We have map updates over the air, we have a concierge call where you can push a button, you get a call connection to someone who helps you make a reservation in a restaurant, and so on. You can use your cell phone to open the car, to heat it up in the morning when it's cold outside, all the things that are really required when you have a car. So Connected Drive has been out there for quite some time. The system itself started 20 years ago. Was designed for a few cars because 20 years ago all the digital services were not that important. Today they are important. And we have on these systems that consist, by the way, out of 300 microservices, about 12 million cars. We're getting every year, because we are thankfully selling 2.5 million cars every year, or IoT devices, very fun IoT devices, to be honest. We're getting more and more cars onto our back end. And because digital services are so important for the company and for our customers, we in addition add new services to the existing fleet. And of course the new cars also get these services. So what we end up is basically growth of the request rate on a yearly basis of 30%. You can imagine if you have traditional IT, you have all these microservices running on shared infrastructure, all the processes behind it, and suddenly you get this immense increase of requests that you run into problems. And you need systems that can deal with this. And for us, this basically means we have really 1 billion requests per week we have to deal with. At some point, you just cannot tackle this with traditional IT. So we decided a few years back, started our journey with Red Hat and with OpenShift in 2016, and decided to have our backend completely migrated to the OpenShift platform. So we started with the connected car application. We are migrating, first slicing our applications from monoliths to microservices, putting them on our OpenShift platform. We have worldwide 4 clusters running, all on OpenShift, and by the end of this year we want to be done with this migration. So it took us, let's say, full-time migration about 2 years, but it came with a big transformation of the culture of the company as well. Today we are running 12,000 containers, and we're not just having the 4 connected car clusters, but 19 clusters worldwide. Because we need to be more scalable in the future, we're really looking into Red Hat OpenShift Dedicated. I think this is a product that helps us in the future when we need to scale even more. We want to utilize the public cloud for us because this gives us the scalability and the resilience we need. We can localize clusters in different markets if we need to, and therefore serve our customers on a worldwide scale in a best way. We really think that the public cloud in many cases is the future for us, especially when it comes to data. You've heard Chris talking about data, how data is increasing over time, and we see this as well. In order to give our customers the best personalized experience, we really need that data. We need the data from the processes, we need the data from the customer in order to really tailor the services to our customers and make sure they get the best possible service from us. We are building our data lake currently up in the public cloud. And of course, then it makes sense to also have, with OpenShift Dedicated, some runtime for applications that can really utilize this AI platform we are building up there. Because in the end, it's all about creating a good customer experience, creating new services, and giving you basically the best experience possible. I'm very excited for the future and see what comes. I hope you are as well. And maybe we see each other again in a few years, where we then explain how we use our AI platform to get you the services you need. Thank you.
All right, thank you, Dr. Lang. Now that's 5 back-to-back examples of how technological innovation is truly disrupting business and entire industries. The key ingredients to broad-scale human and economic change are transportation, how we move goods and people; communication, how we talk to each other; how we manage power, money, time, and resources. A set of key changes in key industries are what really unlocks the next huge phase of humanity. But what that means for us, you and me, is that we will have seen massive change in our lifetimes. Sometimes we see change in unexpected places. I travel a lot, and not too long ago, I was in Vietnam. I was using Google Translate to speak with taxi drivers. I wasn't just asking them to get me from point A to point B. We were actually trying to have something like a real conversation. And it excited me then to see how much that kind of opens up the world. Think of how much more inline translation, like you saw with Optus, would allow. And the most delightful thing about that is innovation never stops, not in the world, not at Red Hat. We continue to build the platforms that help make more innovation possible. And now we're going to show you what is possible today in the realm of event-driven AI and industrial IoT. I hope you've got your dance moves on, because you're going to need them. So let's bring Burr and his team back to the stage. Thank you.
Please welcome Red Hat Global Director of Developer Experience, Burr Sutter, with Sanjay Arora, Hiram Chirino, Jeffrey DeSmet, Stuart Douglas, and Paolo Paterno.
All right, we're about to kick it up several notches. Are you guys ready? Whoa, that's not good enough. Are you ready? All right, I know you're a bunch of IT professionals. We're going to talk about that in a second. But let me tell you a little story real quick. For one thing, though, I want to know, did you enjoy our RHEL 8 and OpenShift and Kubernetes native infrastructure demos yesterday? Well, now we're going to show you something a little bit different. We have built an application in this case, and we're going to show you how we built that application, and then we're going to let you interact with that application. You're going to be my beta testers, because we're going to production here in just a few moments. So be ready with your phone. Now, there's one thing I know about the Summit audience. You are all some of the IT elite of the industry, meaning you know bits and bytes better than anybody, right? Even those arcane commands on the keyboard we talked about yesterday, that's what you know. But we actually live in a world of physical things, and as you saw a moment ago with BMW, right? We live in a world where things have to be connected, and when I say things, I mean things like you see in my simulated factory right here. We have large machines. There might be paint processing machines. There might be metal sheet presses. There might be large industrial fans or conveyor belts. These things have to be monitored, and we have the ability now to monitor them at greater than ever before. But the hard part is, how do we process all that data? How do we receive that massive stream of data, make sense of that massive stream of data, and then do something about it in a real business positive kind of way? So be paying attention to that, because you're going to see this dashboard a lot more. All right, but just remember, physical things have certain physical properties, especially in the large industrial Internet of Things technology like you see here. And one of the key elements to understand is vibration, okay? Vibration is a leading indicator of machine failure. That is how you know it's going to break before it actually does break, because when it breaks, it could cost you millions of dollars in machine outage. Right? If you have a failure in this processing pipeline, you may have a situation where your customer orders are getting backed up, and of course those machines have to go into maintenance. A mechanic has to get routed to go solve the problem. And more importantly, let me just make it easy for all you folks here in IT, because I'm an IT person too. Remember that moment in time when you had an old car? Some of you may still have an old car. You appreciate old cars. But do you know that if you feel a vibration that seems a little bit odd, you probably take it into the mechanic. And the rhyme I like to make is, when things go shaky, things go breaky. And that's the theme of what we're going to be showing you right now. Okay? So let's jump into the architecture diagram. I want to show you that. And so you can see right here we have our sensors. And guess what? You have a ton of sensors in that smartphone in your pocket right now. Pull it out of your pocket or you're going to need it in a moment. Be ready. All right? By the way, I should mention we have special prizes for people here in the room. You got to be present to win. So we're going to basically monitor those sensors in real time. We have to receive a massive influx of data from your phone, and we're going to do that through this technology called Node.js. One of our engineers built this amazing technology, and you're going to see it basically streaming that data in as part of our Red Hat application runtimes. We're going to, of course, receive that massive influx of data with Apache Kafka, because you need something that can handle that at scale, and you're going to see that with Red Hat AMQ. We, of course, have to filter the signal from the noise. We have to know that not all shaking is created equal. Some vibrations don't matter at all. It's everyday vibrations. Some vibrations really, really matter. And we want to make sure we dial in on that through an AI technology you're going to see here also. We're going to then talk about our back-end infrastructure, where we know, of course, we have Salesforce.com, where all our customer data is held. And we want to make sure that our customer orders, which are in flight, which may be impacted by a machine outage, are at least part of the algorithm we use to understand, do we actually prioritize this event to make sure that we solve that problem so we don't have customer satisfaction issues or loss of revenue. That's a key element. Also, if you look at the Quarkus element right there, you're going to see us live code that here on the stage. We're going to build a new REST API endpoint. That's what you're going to see from Stuart in a moment. And we're going to show you what it means to take Java to a whole new level. And then, of course, we have to integrate these worlds. So this is where Red integration comes into play. And we're going to bring in that Quarkus technology with that new API, Salesforce.com, our event stream input. We're going to run all that on top of Knative with its dynamic auto scaling. You're going to see that happen live on the stage also. And you're going to see us build that application integration component. And then, of course, we analyze that data, right? We get the damage record, we understand all the information. We put that in our data grid here, and that's Red Hat Data Grid. And then we have another step which uses OptiPlanner, part of the Red Hat business automation middleware. And we're going to basically determine what is the most impact, or what is the most efficient route to move mechanics from point A to point B. And of course, you see that all on that dashboard that you saw earlier. This is where we have worked incredibly hard to unify and create a coherent application environment, one underlying application set of middleware, so you can run all that, of course, on top of OpenShift, and that's what we're doing right now. You guys ready to get started? We'll go a little bit slower in a moment. Okay, so up first, I want to take you through AMQ. So we have here on stage Paulo. Paulo is my AMQ streams expert, an Apache Kafka expert, and he's going to show us how do we set that up on OpenShift. Paulo.
So thank you, Bur. Let me show everyone how we solved the first challenge. So first of all, our Internet of Things backend needs to be highly scalable, because a few thousands of sensors like the ones in your pockets right now can easily overwhelm our backend infrastructure. But I'm not worried about that, because this is what Kafka is built to handle. But we want also Kafka is to be really easy to deploy and manage. So here we have OpenShift in order to handle our containerized infrastructure. And there is a new software operator, which is under the HenQ Streams product, in order to handle our Kafka cluster running on OpenShift right now. So the HenQ Streams operator provides you a really simple way to deploy and manage a Kafka cluster running on OpenShift with all the related entities, like, for example, topics and users, in a cloud-native way.
Okay, so we saw software operators just yesterday in a big way, and I love the fact that we now have this software operator to run Kafka at great scale, the brokers, the zookeepers, all that. So that's great for operations. But one of the things I hear from developers all the time with this Kafka thing is it takes me weeks to get my IT department to provision a new topic, and that's a huge challenge. I don't want to wait as a developer. So how do we solve that problem, Paulo?
Yes, absolutely, and we have been hearing the same story. So I'm excited to show you a new self-service console. Using this console, the users can see all the topics already provisioned in the Kafka cluster running on OpenShift with all the related metadata like partitions, replicas, and consumer. But the users with rep permission can easily create a new topic. So just fill in a name, let me say sensor stream, and then, for example, setting the number of partitions, the number of replicas, the data retention policies that can be based on age, on storage, or the compacted one, and then, if needed, adding some more new advanced configuration, and then just clicking on a button, the topic is provisioned in a few seconds.
Oh, wow. So right now, we just provisioned a new Kafka topic with a few points and clicks. Can you imagine that self-service, empowering your developers at some point in the near future? Thank you so much for that, Paulo. That is fantastic.
My pleasure, Bur.
All right, so up next, I mentioned that we have more of our back end to talk about, right? We have some really cool things to show you there. And now we want to talk about a technology called Quarkus, where we've changed the game for Java developers, and you're going to see exactly why right now. So right now we have Stuart on the stage. He comes from way down under, and he's going to walk us through what is Quarkus. Can you tell us about Quarkus?
Quarkus is our supersonic subatomic Java, where we've optimized Java for a Kubernetes and OpenShift environment, with all your favorite frameworks and APIs, plus we compile it down to a native executable.
Wait, you said native executable. Well, tell me more about that.
Well, there's no JVM involved, it's just a normal native Linux executable.
Okay. Now, Quarkus is a really funny name. Wouldn't you guys agree? Now, but I like it better with your accent. Could you tell me where the name comes from?
Well, a quark is a reference to the subatomic particle, because it's very small and light. And the us refers to the heart of software development, us humans.
Okay, but it's smaller.
Incredibly.
And faster?
Dramatically.
And it's not some funny Australian exotic animal?
No. So seeing is believing, so I'm going to show you what Quarkus can do by finishing off a half-complete Quarkus app live on stage. So what we have here is a machine maintenance API of our application, which is a JAX-RS and JPA-based REST app. It has two endpoints at the moment, one that lists the machines, and another one that shows the maintenance history. Now, at the moment, this isn't that useful, because even though it tells us how much damage a mechanic repaired, it doesn't tell us what the final health of the machine was, so let's fix that now. So, as you can see from the URL here, this isn't actually running on my laptop, this is running on an OpenShift cluster, so I'm going to do some cloud-native development. Now, the first thing I need to do is connect my laptop to the cloud by running the remote dev command, and now we're connected. Now, the maintenance history is stored in the maintenance record JPA entity, so I'm going to add a new field here to store the health. Now I'm going to go to my JAX-RS resource, and I'm going to expose that new field to the application. Now if I just go back to my browser and hit refresh, we should see the change. So now I've got this final health field there.
I love that edit, save, refresh development model. That's fantastic.
Yeah, and this is running on the cloud too in an OpenShift pod. This is true cloud native development.
Awesome.
So now we've got this information. What I'm most interested in is the current health of the machine. So let's add a new endpoint to do that. And to do that, I'm going to use something called Apicurio Studio, which is an API designer and part of the Red Hat Integration Studio. Now, I'm going to add we can see that I've got two paths there. I'm going to add a new one. Now I'm going to add a path parameter, which is of type integer. Now I'm going to add a get operation. Now this operation can have an ID called current state, which will translate into the Java name. Now I'm going to set the content type, which will be JSON, and add a response type, which can be machine state. Now I've designed my API, I need to get it into our application, and to do that, I'm going to use the code generator. So I'll just click through this wizard here, and the end result of this will be a pull request on GitHub. It just takes a few moments to generate. So once this has been generated, I can review this as normal and see what changes it's made. You can see my new method there. That all looks good. So I'm just going to be a bit naughty and merge my own pull request, and then sync it with my local workspace. You can see here, we've got this new method that I just designed. So now let's implement it. Now I've actually got a method here, calculate state, that has most of the logic we already need, so I'm just going to call that. And I'll update this to include my new field. Go back to my browser, to my new endpoint. And we should see it. Crikey.
Oh, wow.
I've got a query exception. Sorry, 2 secs. I've got a typo.
Yeah.
Whoops.
Rehearsing backstage.
All right, we'll just pretend that didn't happen. So you can see here, I've got my new API with the current health of the machine. Now, because I've been doing development, I've been working on the JVM with standard Java libraries, but we can also compile this down to a native executable. So if we have a look here, here's one I prepared earlier that's running on OpenShift using only 20 megabytes of RAM. And this isn't a Hello World app either. This has JAX-RS, JPA, transactions, all the stuff you need to write an enterprise app. And because it's a native executable, it will also start really quickly. So if we see here, I can just scale this up to 20 pods. If we have a look, we can see these pods coming up now.
This is a full stack enterprise Java application deploying right now into OpenShift, scaling out, and you can see they're already running. So that is fundamentally game changing. And this really matters a lot. We're building an application here that has to dynamically scale based on an influx of sensor data. So you have to think about that for a moment. We're going to basically pound this system to death. And if you don't have live scaling like that with a super small, super fast runtime, it completely changes the way you think of Java for sure. Thank you so much for that, Stuart. Totally awesome stuff. Hard live coding in front of several thousand people. Okay? We got more to show you though, all right? So up next is Hiram, and what we want to do now is talk about how we integrate these technologies. How do we take an API like you saw Stuart just create, as well as Salesforce.com, but also take that influx of sensor data and bring all those worlds together so we can basically understand better what our damage looks like, what are our repairs, how should our repairs be prioritized. So let me introduce you to Hiram. He's a key part of our engineering team, part of the Red Hat integration team specifically, and he's also our Apache Camel guru here on stage. So Hiram, please show us more about what you have there.
Hey Bert, I'm going to demo to you guys how we can easily add Stuart's new API endpoint in an integration pipeline. This pipeline's job is going to be to combine data from different systems so that we can schedule machine repairs. I'll be doing this with Fuse Online, which is a part of Red Hat integration. Let me select the integration that we're going to be updating here. Okay, so this first step here is connected to the Kafka topic that was created earlier. It's receiving all those machine sensor events. We then need to understand how customer orders are linked to machines. So we're going to query our corporate asset management system in Salesforce, and that's going to let us know the cost of failure for the machine reporting the event. We then combine all that data and map it into a repair record, which we then send to an API which deals with scheduling those machine repairs. What we'd like to do is improve this by prioritizing based on which machine is closest to failure. So let me edit this integration. And we can use Stuart's new API endpoint to get the current machine health and include that in the repair record. I'll add a call to his API here. And let me scroll down and select his history API. Here's his new endpoint. All we need to do now is add a data mapping step, which lets us configure the input into his API. And let me map machine ID into the ID parameter. Finally, let's also update this last data mapping step. It's combining information from the original sensor event and Salesforce and mapping it into that repair record. So let's also map in the health field from the API response into the repair record, and now we're done. And we can publish. In a few seconds, this is going to be running as a Knative service thanks to a new upstream Apache project called CamelK. Okay, Bert, we're published. We just need a whole bunch of sensor events sent into that Kafka topic.
All right, so it's already deployed out into OpenShift, right? OpenShift 4.
That's right.
Okay, and so we want to also see our Kafka Grafana dashboard because we need a big stream of events flowing in, right? So let's make sure we got that. All right, fantastic. You see there's no messages right now if you look over here. So what we need is a huge influx of data. All right, so just going to give you an example of what this looks like. I happen to have a ton of sensors right here in this smartphone right now. Should I give it a try? Are you ready?
My console here shows the deployment. It's got 0 pods running. As soon as you shake that phone, that
all right, so this is where you
up.
see Knative auto-scaling responding to a series of events. So I'm going to get shaking right now. So here we go, pushing in accelerometer data at great volume into this application. Let's see what happens here. Okay, we've already spiked up 334 messages per second on that side, and you can see 100 pods coming online right now. There we go, 16 available, 19, 21. That dynamic auto-scaling of Knative happening right there, right now. All right, fantastic, look at that. What do you guys think of that?
You did a great job, Bert. You shook that phone, generated a ton of Kafka events that caused Knative to scale our integrations up from 0. And did you notice how quickly those pods started up? That's because CamelK is also running those integrations using Quarkus.
CamelK on Quarkus, dynamic auto-scaling out with Knative serving, 101 pods now available. Look at that, fantastic. Okay, for those of you watching on the live stream right now, this is where you want to tweet your friends, let them know some more cool things are about to happen, because we have even better things to show you. And I know all of you right now are anxious to be shaking your phone, aren't you? You're going to get a moment. We're going to have that opportunity. But right now, we want to tell you a little bit more about our application. So you've seen how we architected the back end. But let's talk a little bit more about the things you see more on the front end of this right now. And we want to talk about artificial intelligence, specifically machine learning. And we have here with us on stage Sanjay from the office of the CTO, where they worked really hard to train a very special model to help analyze certain vibrations and understand what that shaking needs to look like. So Sanjay, can you tell us more about the role of the data scientist and the machine learning on top of OpenShift?
Absolutely. So analyzing data like this for patterns is a perfect fit for some of the technologies we have been working on. One of those technologies is called Open Data Hub, and you can check it out at opendatahub.io. Now, the workflow of the typical data scientist involves data curation, exploratory analysis, model training, validation, and serving. OpenShift and Open Data Hub let a data scientist do all of these using their favorite open source tools and at scale. So let's see how one would get started with Open Data Hub. You can go to your OpenShift console, select the developer catalog on the left, search for Open Data Hub, and install it right there. This gives us access to a Ceph instance to store our sensor data, as well as Jupyter notebooks. These notebooks are the main interface between data scientists and their data, and they serve as the arena where all data modeling takes place. So let's take a look at a notebook. This is what a typical notebook looks like. You can write your regular Python code, and in this case, we plotted the sensor time series data.
Okay, so I know one of the greatest challenges with getting data science and AI ML integrated into your overall development, cloud native development world is capturing data, training a model, performing iterations on that trained model and coming up with your hypothesis. So how did we train our model for this application?
Yeah, so we had to get a bit creative there. This is a simulation. We obviously don't have real machine parts here. So we want our audience members, all of you, to serve as proxies for the machines. Now, it is very hard to tell someone to move like a broken machine versus a healthy machine. So we picked a few specific moves that represent how machines with various levels of damage would vibrate. We spent the last few weeks training our models around these movements, and the goal for all of you is to emulate them as well as you can. But let's first take a look at how we trained the model itself. The first step was to collect the data. And some of our colleagues wrote this great app that lets us do just that. So as you can see on the screen, we have a volunteer showing the shake motion. And a user would click on Train Model, execute the motion with the phone in their hands, and submit the data, which we would then use as our training data. Some very enthusiastic Red Hatters, including Burr, generated a ton of data for us in our Raleigh office. Let's take a look.
Those are our models to train a model.
And at this stage, we have training data. So a data scientist can get to work. We would go back to our notebook, load the data, refine it, train our model, and once we are satisfied with our model's performance, persist it and create a REST endpoint. This REST endpoint will then evaluate your moves. So Burr, we have a few thousand people in this room. We should get them involved.
Yeah. Well, I think this is where we reveal what our little application does. And we get you guys a chance to connect to our back end. You guys ready for it? All right. You got to go to red.ht/demo2019. Red.ht/demo2019 on your phone. You will see that the game will begin shortly because we have it paused right now. Are you ready? Okay, let's turn it on. Let's see that first one. You'll notice the shake there. Sanjay will click on the shake icon. And all you got to do is do it like you saw with Kyle Buchanan, our training model, training our model. Okay? And you'll notice you'll score points. You'll see the points show up there. And then there we go. There Sanjay got the shake. All right? It's that simple. And you're probably thinking, wow, we have a whole data scientist team to worry about that. Exactly. This is how we do it here. Okay? But actually, there's a couple more fun things we added to the application. So if we now could push out and dynamically add the X and the circle. There we go. So there's your circle. All right? Come on, get that phone moving there. I don't see enough waving. Oh, now we got 100.
Yeah.
Oh, I see about 1,000 of you waving now. All right? And now the X is kind of tricky. Got to go kind of slow. All right? If you're over aggressive about it, it won't pick it up. Fantastic. Okay, so we have tons of data flowing into the system right now. What do you think about that?
Yeah, this is great. And I would like to clarify one point. So each of you is associated with one machine. So in my case, I'm associated with machine E, which is in the lower left corner of my app. And so the machine learning model actually thinks you are the machines. And when you move, it thinks the machines are vibrating. It then evaluates what move you made and how good it was and updates the damage on that machine.
Yeah, you can see with the machine E right there, it actually is orange because, now the sensors are picking up damage associated with it. All right, now, I know you guys are having fun, but I need everyone to stop. Check that out. We took control of your phone. All right, be ready. There's more coming. Now, we actually have to show you more of our back-end architecture here because there's one more thing that is incredibly important to understand. And when you see all our machines up here on the big screen, you have to understand that we have to route mechanics in an optimal way. Just like you take your old car to the mechanic when it starts shaking, we got to make sure that our mechanics move to these big industrial machines and start fixing them. So what we have here right now is Jeffrey, who's part of our Red Hat business automation team, process automation team, and he's going to talk to us about OptoPlanner.
So routing repairman might seem simple. After all, we have a prioritized list of repairs. But it's actually quite complex. We have a limited number of mechanics. We need to decide for each mechanic which machine he will fix. And there's a traveling time between all of the machines. So we need to do that efficiently. And there's also a heck of a lot of audience members here detecting machine damage. So we need to do that as efficiently as possible, and we're going to use the business automation product, and specifically my baby OptoPlanner to do this.
Okay, so how does OptoPlanner help us with a problem like this one, though?
Well, OptoPlanner is an AI constraint solver. It optimizes planning problems by using advanced algorithms. So for example, it can solve the vehicle routing problem, in which we need to send a fleet of vehicles to a number of locations across the country. And when we do that, we want to decrease their travel time, and we want to decrease their fuel consumption. And with OptoPlanner, we can reduce their travel time and fuel consumption by 15% or more. Obviously, saving fuel consumption is good for the environment, and it saves some of our customers hundreds of millions of dollars per year.
Hundreds of millions of dollars per year just by a more efficient routing. That is fantastic. Now, how does it make an impact on our mechanics?
It's basically the same problem. Instead of trucks, we have mechanics, and instead of locations to go to, we have machines to go to. So it's the same problem. We want to reduce their travel time, so the mechanics spend less time walking around and more time actually fixing the machines. This productivity boost allows us to compete, allows us to keep all the machines afloat while you guys send in machine damage. So in the scenario I've set up here, you can see all the machines are damaged. The three machines in the middle are heavily damaged. We have a red machine and two oranges machines, but even the green machines have some damage. So there's actually a reason to send a mechanic to all of these machines. Now, which machine should we fix first, and in which order should we fix these machines? Now, you might think, let's just send the mechanic to machine D, because that's the most damaged machine. But that means that he need to head back to machine H and then to machine E. And that's actually not efficient because he will spend a lot of time traveling between those machines. On the other hand, we could find the shortest path, which is in the academic world known as the traveling salesman problem. But that's not going to help, that's not going to be super efficient either, because then we might lose some of these machines. So we need to do something in between. So I'm going to add a mechanic, and I call this one Mario. And you can see the order in which Mario will fix the machines. Let me just zoom in for you. So here you go. So Mario will first go to machine H, then machine D, and then machine E. And you see as he goes to machine D, he fixes machine H along the way, because that's just more efficient.
I see it, 1, 2, 3, and you can see Mario standing right there by the break room. So what happens, though, if one of our machines really sees a lot of damage, starts deteriorating rapidly, really falling apart?
Yeah, if all of you guys, for example, focus on machine C, it gets a lot of pressure. So let me simulate that. I'm going to put some pressure on machine C, and you can see that OptoPlanner immediately changes its mind.
That is fantastic. So it still maintains the optimal route based on what it sees right now in real time.
Yes. So let's get back to our factory floor.
Okay.
Shall we let him go?
Well, I think we should let the mechanic loose, see what it looks like here.
Yeah, here we go. So as you can see, the mechanic starts fixing the machines in the order that OptoPlanner optimizes.
Well, I think at this point, with mechanics in play, we're ready to start playing the game again.
Hold on there just a second. There's thousands of sensors here in the room. Actually, 1,030.
Yeah.
So that's a little bit a lot for just one mechanic. So let me bring us a second one.
Okay.
I call this one Luigi.
The green one there. All right, fantastic. So, as you guys know, right, we basically have this application running right now. There's 1,000 of you connected to the game or more. You can go to that same URL, you see it at the top of the screen right now, and get connected to our game because there are special prizes for the top 10 winners. I mentioned that earlier. Maybe you weren't paying attention, but now you can join the game. Also, I'll tell you one other trick. If you actually score all 6 of the things you're about to see, you get 1,000 bonus points. Remember that one. That's for people who really want to be hardcore about this. Okay, now, we need to get this game started one more time, so go ahead and turn it back on for me. Let's let people play a moment. All right, you want to make sure that you pick that shake motion and get that one nailed, or you want to pick that circular motion and make sure you nail that one too. These are all, look at, there's like 1,000 phones waving at me right now. That's awesome. Okay? And of course, you can see Sanjay's playing the game there. He's knocking down some points, and you can, wow, Keen, Sting, look at that one way up there on the top leaderboard there. Woo, yeah, fantastic. Okay, stop one more time. Okay. You guys like that one, don't you? All right, we have the power up here. Now, the team, we wanted to challenge our AI team. We're like, okay, circles and X's, that was easy. The training that model wasn't that hard at all, actually, you know, separating different types of vibrations. So we wanted to take it up a notch. So I challenged the team with a couple of different things. If you remember that famous movie from 1977, it's called Saturday Night Fever with John Travolta rocking the disco stage. This is my era, people. That's what we're talking about here. So we actually have added a couple other things. But right now, I have a couple other people who are going to come up on stage and help us do this right now. So get on up here. You know, we had some volunteers who want to ensure that we make you guys understand how these motions are created. We're going to get everyone down here. Fantastic. Okay. All right. Now, we're ready. Let's unpause the game and show them the roll motion. There it is. And it's that famous John Travolta move. Shake it. And let's add the fever move. Shake it. There it is. Shake it. Shake it. Oh, wow, look at you guys going. Woo! As you can see, we have people scoring huge points there. All right, pause one more time. Again, we have the power. You guys are looking good up here. That's fantastic. Now, the younger people on the team were like, bro, that 70s stuff is cool and all that. I know about it because of Fortnite. You guys with me? Your kids playing Fortnite, they learn those same moves. I learned about them more in the real, but that's a different issue. They're like, well, we need to train this AI model to do one more thing. You guys ready for it? We want to show you the floss. Let's add it in there and get going. Here we go. If you want to win this game, you got to score those points. All right, let's stop. Game over. Wow, look at all you folks. Think about this for a second. Look at it. We had 1,000 people playing the game live with us right now. We had over 12,000 transactions go through our system, scaling out on that back end you saw earlier with all that infrastructure you saw us put together. And of course, we had 9,500 recognized motions. That is absolutely incredible. And if you remember, all that Red Hat middleware that you just saw, we pulled together in a coherent, unified application environment running on top of OpenShift where you guys could interact with it directly. Absolutely fun stuff. So, I know you're super excited about what you just saw. You can come to our booth, the DevZone booth, at 1 p.m., and you can actually get a behind-the-scenes tour of all the other cool things that went in here. There's actually a lot more cool things you didn't even see today. So just keep that in mind. All right, just 1 p.m. DevZone. Now, I recognize we're IT professionals here. We don't all dance. I'm a little out of breath because of all that movement. All right, but you do innovate. And oh, by the way, I should mention, if you see your name on your phone up here, come see us at the end of the keynote. Don't rush the stage right now. We do have special prizes for our top 10 winners, okay? But you do innovate as IT professionals, and one of the things you want to see right now is yet one more award given away for the Innovator of the Year. So I'd like to welcome back Marco and Chris. Thank you.
Please welcome back to the stage Chris Wright and Marco Bill Peter.
Thank you, Burr. Thank you. Wow, Chris, want to do some flossing? Every year it gets more difficult to pick the most outstanding and innovative projects from the pool of nominees.
Well, okay, we look at the impact to business, the nature of the transformation, really elements of community and openness. We also look for projects that are unique and creative, you know, cool.
Cool, yeah. And the top 5 become our Innovation Award winners. You've heard from them throughout the week. All of these organizations are winners, though. Not because we picked them, but because they are showing us the way forward. This year's top 5 include BP, where they're developing things differently with OpenShift. Deutsche Bank is working to create everything as a service.
And for Best Supporting Actor, Emirates NBD using data to personalize customer experience. HCA Healthcare, enabling machine-enhanced human intelligence. And Coles, they're all in on cloud and open source.
And from these 5 winners, you choose the winner, the Innovator of the Year. Chris, give me the envelope.
Dude, you're killing me.
What?
Seriously?
What? Seriously?
Hey guys, forget a little something back.
Oh, thank you. Thank you.
Glad someone's in
well,
charge
while you're here, Jim, why don't you do the honors?
Oh, it's good to be the CEO. All right, I'll do that. Did PwC certify this?
Absolutely.
All right. Oh, the winner, I'm very excited. I did not know literally until this moment. HCA Healthcare, saving lives. Woo.
Behind you.
Oh. Hey. Congratulations. Really, truly an inspiring story. Congratulations. All right. Who gets the honors?
Congratulations.
There you go. Absolutely. All right.
Right you in the back.
Thank you. And again, congratulations. Truly inspiring. Thank you. I have to say, we spend so much of our time, deep in technology because we're passionate about it. We love it. But having an opportunity to observe what that technology can do to literally have life-changing impact, it's an extraordinary thing to see, and it really helps personalize everything that we all work so hard to do. So again, thrilled with all our Innovation Award winners, and certainly HCA. It's just such a great story. So Summit has brought us so many new things. A new version of RHEL, a new version of OpenShift, a new logo, and even new ways of working. And so we are so excited to have you here to share them all with us. For those of you who've been with us for a decade or more now, we really appreciate you being here. And for those of you who've just started to join us, welcome. It's great to have you. I went to a number of receptions last night, and several people said to me, God, we're here for the last Red Hat Summit. Just want to be clear, we're not going anywhere. The party's definitely not over. We have a great party tonight, and we will see you for Red Hat Summit next year in San Francisco. It's going to be bigger and better than ever. Thank you so much for being here. See you tonight.